Hello everybody, I'm Apasud and welcome to my course on secure communication and network. In the last session, we have discussed about the communication protocol, that is X.25 frame relay and ATM. In this session, we'll be discussing about the multi-layer protocol. So let's start with it. So with the multi-layer protocol, we could send different type of protocol, but by putting the labels on them, we could then govern or control the routing that would take, so we could ensure that our traffic went, say, on one type of network instead on the other type of network. Now the thing is that we saw sort of say that the protocols operate at a layer, but that went quite fictitious because a lot of protocol actually operate at a various layer, and so that the rules are not absolute. So we can take something like MPLS. It's very good argument that it's really more of a layer 3 than of a layer 2. You even take advantage of protocols like ICMP. ICMP stand for Internet Control Message Protocol. We all know that the ICMP is a well Internet Control Message Protocol. It was meant to be the layer 3, but if we really look at the ITMP package, it wrap up in the IP packet. If IP packet is layer 3, then ICMP must be at layer 3.5. So we see that something they are confused over these. You are even they say that the same as TLS. TLS is transport layer security. Well, that should be simple, yes, but what does TLS do? It sends us a session, so in some way it operates a little bit above the transport layer as well. But one of the thing that was decided was we could always define a protocol at a lowest layer it first appear at, and that made it bit little bit clearer, even though we could say that there are arguments that these are multi-layer protocol, in even fact that we just define them according to their lower level layer in which they appear. Another one that very much evolved today is DNP3, that is distributed network protocol, and that is used in a lot of industrial control and SCADA devices. And it's something that the traditional IT network person does not have to too much worry about, because these were separate lease lines connecting our sensors and walls and so on. But now these are starting to run through our organization network, and it sometimes uh, we have to pay attention as well. Are they in some way a point of access or a breach to the rest of the network? The same thing was Modbus, especially in the oil and gas industry. We saw that the Modbus as a way then to allow the communication out to, say, for example, sensors and controllers on pipeline and so on. Telecom industry for the many years used uh, well common channel signal and SS7. This was the way to do. Then the signaling and to manage the various network activity. A lot of these are being replaced, but there's still a lot of them still in use. And these have been pointed of a breach and access. Uh, breach and access for hackers over years as well. So some of the risks with these multi-layer protocol is uh, is the idea of tunneling. Okay, so we see the some of the risk is the idea of tunneling. What happens if I start up the HTTP tunnel and it will be accepted and it runs there on port 80, but now I can bury FTP say FTP traffic into it. So I use that affected pipe of HTTP. I put malicious code into it, and it's not necessarily properly filtered, and because a method of attacking a system is behind. We have seen the same thing in the DNS traffic running over the port 53, for example. The problem is that many of these can become hidden or covered channel, they can bypass some of the controls we had in place, some of the filters, because the traffic looks okay. Well, this is just DNS traffic, but it doesn't pick up the fact that there is something that's not DNS actually going over the port and over the pipe. This can allow us to do things like virtual local area network hopping. So now I'm able to get around the barriers I had between my various VNs. We have also seen this, of course, with SCADA communications. SCADA, as we said, often use DNP3, and then and that now is running over TCP/IP. That means that in some cases the filter and firewall are not able to really see if there's anything malicious within the NP3 traffic. This also sets up for bypassing the authentication of devices, that being able to run a mid, man in middle attack. So this is what we are having as a multi-layer protocol. So now let's look forward and go to our next thing, which is about the fiber channel Ethernet and IC square. So here we have another control we have, and we are using for a number of years, fiber channel over Ethernet. This is where we know that the fiber optic cable is a physical layer. It's our actual cabling itself, and we often use this for storage networks. But can I use a converter so I can take now my fiber channel traffic and run it over the Ethernet cable, which of course is running over, say, existing copper infrastructure. So instead of having to invest in fiber, I can then use the copper infrastructure we already have, and we just encapsulate the fiber channel communication within the internet package. This means that we can share that network, the Ethernet network, and both Ethernet traffic and over our channel control communication, fiber channel storage communication. Now this is usually used just within one building, such as data center, to allow for the storage and store. But when I want to go outside, then we often use, that is, iSCSI. So full form of that is Internet Small Computer System Interface. It is also for storage networking, network storage standards, and it's not expensive as fiber channel. It's then based on IP, and it enables us to do the file storage, transmissions, and retrieval over most type of networks, the LANs, the WANs, and internet. So this allows using the iSCSI to convert to a remote storage device. So now when we are having a physical fiber, then the other things what we are having is voice over IP. That is, you can say, VIOP as well, that is voice over internet protocol. So means that I'm going to convert my voice into a data type, data traffic, and this has been a huge benefit as we move towards the converged network. The ability to combine traditional telephony with then data communication enable much better for a lot of our application as well. But here we use the protocols such as real-time protocol or secure real-time transport protocol, which is RTP or SRTP. This allows us to have encryption using the advanced encryption standard, as well as integrity using secure hashing algorithm. When using this, I could then provide confidentiality, integrity, and authentication of devices. The challenge, of course, with voice VIOP, or which can say as in voice over internet protocol, what we are facing uh, facing is now my voice traffic becomes susceptible to the same type of attack as my data traffic previously did. So this is what we are having, more control, which talks about the multi-layer protocol, and voice over internet protocol. So thank you so much for joining me in this session.